Welcome to the Oxygen Alliance YouTube channel, where we bring you videos on installation, maintenance, and various trainings on oxygen equipment and devices. If you have comments and or questions, drop them in the comment section below or write to us info@oxygenalliance.org. Remember to like our videos, subscribe to our channel, and hit the notification bell.
Alright. Thank you everyone for joining us. Now it's time for us to start our call. Our apologies for starting this late than we planned. So thank you for joining us for today's partner talk brought to you by the Oxygen Alliance. My name is Janet Douglas and I'm a biomedical engineer for the Oxygen Alliance. And I'm excited to be your host today. I'm hosting this call from Lilongwe, Malawi, and I would like to know where you're joining us from by typing your name and your location in the chat. If you want to be added on our emailing list and get notifications of our upcoming events by the Oxygen Alliance, please type your email in the chat. Today, we have a very interactive presentation on dry heat sterilizers, and this will be presented by our special guests, who are none other than Engineer Remy Mushi, who is a biomedical engineer at Kilimanjaro Christian Medical Center Zona Hospital, and Engineer Joseph Nimba, who is also a biomedical engineer at Ligula Referral Regional Hospital in Tanzania. Please stay with us. I'd like to encourage everyone to take your notes, as we'll be looking forward to hearing your questions and your comments at the end of the presentation. So normally we do take questions and comments at the very end of the presentation, but for today, we will take one question after the first presenter is done presenting. So after Engineer Remy is done, I will take one question from the audience and then we'll move to the next presenter. Without wasting much of your time, I would now like to hand it over to our first presenter. Over to you, Engineer Remy. Thank you.
Hello, good afternoon, everybody. I hope everyone can hear me loud and clear. Just raise a thumb as we proceed if you hear me loudly. Okay. My name is Remy, as I've been introduced. I'm from KSMC Hospital, and I'll be together with the second presenter, who is Mr. Joseph. Okay, I see there is a trouble connecting with him. So today we are going to discuss a topic concerning the dry heat sterilizer. I think some of us are familiar with the terminology heat oven as how it's mostly being used. And today we are going to discuss it in details and see what it does, how we service it, and how do we maintain it in general. You are warmly welcomed. So what is a dry heat sterilizer? A dry heat sterilizer is a medical equipment that is used to kill the microorganisms such as the bacteria, fungi, and viruses by exposing them at a higher temperature without the use of steam, as how it is commonly used in most cases. This method, it relies on the use of temperature as well as time in order to ensure there is a maximum sterilization in the load or in the material or in anything that you are planning to sterilize. And this dry heat sterilizer is used in some cases because there are materials that are prone to damage or change of physical properties if they're exposed in the presence of moisture. Such materials can be powder, they can be chemical compounds, and other materials that they can change their chemical properties or physical properties. And if we look on where this dry heat sterilizer are being used, they can be used from, they vary after all, from a tabletop design up to a large scale dry heat sterilizer, which are used in for industrial purpose or for sterilizing bulk of volumes. And they are mostly being used in the research laboratories, medical settings, as well as in industries. And what do they usually sterilize. In most cases, they sterilize the powders, there are chemical compounds, there are glasswares, metal instruments, surgical tools, and other more that we cannot finish mentioning them all. These are the sum of major things that are usually being sterilized in this dry heat sterilizer. Okay, so as we proceed, there are mainly two types of dry heat sterilizer. There is a static air sterilizer and there is a forced air sterilizer. By starting with the static air sterilizer, this is a basic type of dry heat sterilizer, which is simple in design. It does not have any kind of complexion, which means that it has simple dials like change temperature, change time, and it's also easier to maintain. And if we look at the price tag, it's affordable, much way affordable than the post-air sterilizer of the same volume. We are considering of the same volume. If we have presuming that's a 6 meter cubic static air sterilizer and 6 meter cubic dry heat sterilizer, the static sterilizer will be having a affordable price. And when we look on it, on the downside of it, it takes longer time to complete the sterilization cycle. This is because it relies on the natural convection of air inside the chamber to ensure that all parts of the load or all parts of the material that you needed it to be sterile, it has to get there enough temperature. But we have also faced some scenarios that will be discussed later on the maintenance and troubleshooting, that sometimes if it's hugely packed or densely packed, the sterilization may not be successful. We will see it on the later part of the presentation. The second type is a forced air sterilizer. The forced air sterilizer, it's a type of dry heat sterilizer which has an addition of fan to encounter the downside of the static air sterilizer. We can see simply it can have a shorter time of sterilization or shorter cycle time. It relies on fan for convection of the air inside the sterilizer, but due to addition of technology inside this air sterilizer, it had an increase on the complexity, its complexity. Means there are addition of some parts, some circuitries, some sensors inside, so it may ensure its functionality. It's also expensive due to the same addition of technology, and it will require you to have a proper knowledge on how to maintain it. With that in hand now, we can come to discuss the parts of this dry heat sterilizer. And we are going to discuss all of them, the ones that are found in static air sterilizer as well as in forced air sterilizer. The first part is a heating element. A heating element, it's used to convert the electrical power or the electrical energy into the heat energy by dissipation. And we are all aware of how the heating element changes this kind of energy from electricity to heat. And in most cases, the type of heating element being used, it's made up of tubular or ceramic or metal alloy, depending on the volume or the volume of the chamber. Because what matters inside, it's not only about having just any kind of heating element, because if the load is huge, it means you need to have a heating element that can produce massive amount of heat within a desired time. Otherwise, if you just replace either ways, you might not get the satisfactory results from the sterilization. The second part is a temperature control. As we can see, there is at this picture, near here, there is a gauge up on the top, and on the bottom of or beneath the gauge, there are two knobs. So temperature control system, it can be built up from a simple dial or simple design up to a complex system, and it is packed with sensors for precision of data that are acquired inside. As we know, it's full of analog system. So when you talk about the simple dial, it can be just select the temperature or the time and start the sterilizer. But in a huge machines or in the large scale dry heat sterilizer, which are mostly used in industry or even in medical setting, that requires to sterilize the bulk of volume, they may have much more complex system for control of the temperature. The chamber is the volume or is the hollow inside the dry heat sterilizer. This chamber is made up of stainless steel only because we need the temperature inside to be handled or to be maintained without much of dissipation. And for stainless steel, it has ability to handle this amount of high temperature that is being subjected to the machine. So the insulation part, it is used to protect the equipment as well as the user from danger of injuries. Because if there was no insulation, it means the user would have been open to physical injuries, and also the circuitries inside the machine would have been exposed to either melting or malfunctioning. So there is a need of an insulation. And in most cases, the kind of insulation here being used is a glass wool, which is very good at insulating the chamber. So the chamber is usually surrounded by this glass wool to ensure that there is no heat loss towards the machine or towards the door that can actually injure the user of this equipment. And then there is a door seal, the fifth part. The door seal, as we can see in the picture, where the hand is over there, there is something like a rubber. That is the kind of, it's a way of preventing heat loss from inside the machine towards the surrounding, or inside the chamber towards the surrounding of the machine. This kind of door seal can either be made of a rubber or silicone. The door seal is very important to ensure that there is no sabotage for during the sterilization process. And last part, or the sixth part here, is safety features. The safety features comprises of the alarming system as well as the safe relief valves, in which the alarming system is used to alert the user to act as per required. This alarming system, they are directly connected to the sensors, temperature sensors, from a different part of the chamber or of the equipment. And this safety relief valve is to ensure that there is no much of heat being generated more than the one that is required. Also, as we know that the rise of temperature will also lead to the rise of pressure, in which the safety relief valve here comes in handy to ensure that there is no any fatal damage to the equipment. So as we have already seen all of the parts of the machine and types of the machine, now we can work forward to look on the sterilization cycle being used in here. The sterilization cycle comes at different modes in this machine or in this dry heat sterilizer, in which we can sterilize our materials or our load inside at a temperature of 160 degrees, in which it will take us 120 minutes for sterilization. It can also be 170 degrees or 180 degrees. And as we increase the temperature, also the time decreases, but it's not in all cases. It will depend on what do you need to sterilize. And it can also rise because in most cases, we have the temperature around 160 to 180 degrees for this dry heat sterilizer. But for special cases, such as for pharmaceutical industries, we will need a temperature up to 250 degrees. This is because there is terminology being used, the depriogenation, in which it's a way of demobilizing or killing of this virus inside the chemical compounds, the virus that can cause fever inside the chemical compounds, which are used for manufacturing of drugs. Okay, on the sterilization cycle here of this dry heat sterilizer, the sterilization cycle is made up of 3 stages, which are already bolded here, but we have included the two stages just for those who are not aware of how to use it at all. There is a loading part in which you insert the materials or the things that you need to be sterilized, and there is a heating phase. The heating phase is where the heating element inside raises the temperature from the one that was in the room temperature up to the desired or demanded temperature that you have already set. If it is 170 degrees, it means it will rise from a room temperature to 170 degrees. That is the heating phase. And there is a sterilization hold. Sterilization hold, this is a period where the temperature inside the chamber is being held at the same degree. Means even if there is a fluctuation of temperature inside, it's going to be very minor, because the target here is to ensure that that temperature of, presuming it's 170 degrees, has to be maintained for a specific period of time in order to ensure that the load inside is completely sterile at the end of this sterilization hold. And the third stage, or a fourth here at our place, it's a cold phase or cooling phase. Cooling phase is a stage where the temperature drops from the one that you demanded or the one that you set up to a lower temperature. It can be around room air, or it can be around 80 degrees, depending on how fast you want to take out your load. But it is mostly recommended to ensure that the temperature inside is lower, so that it does not burn you on the way as you take out the load, because the temperature of 180 degrees or the temperature of 120, the kind of energy that it possesses, if you put the hand inside it, it can give you even a third burn. So it's really important to ensure that this cold phase drops the temperature up to the safe temperature, which is around 20 degrees up to 40 or 50 degrees, or even 60 at some cases. And there is an unloading part. Unloading part is the removal of your sterile equipment or sterile material from the sterilization chamber. And with all those stages being passed through, there is also a need of performing validation on this sterilization process, in which the second presenter will be showing you how do we check for validity of the sterilization process, because this validity is only targeting to show the efficiency of the sterilization. Thank you very much for listening to the presentation, and now I'll be handing over to the second presenter.
So thank you very much, Engineer Remy, for that wonderful presentation. I would just like to remind our audience that we launched the BME Konza app. And if you'd like to access this app, you can just search it on Google Play Store by typing BME Konza, and you can now have access to the app. The app has been designed specifically for biomedical engineers to be able to interact, ask questions, get clarity on specific machines. If you're having troubles in troubleshooting the machine and all that, you can ask questions. It's a community platform where other engineers are also there to help you, as well as it has given you the access to some of the manuals. So please don't forget to just search it and have access to the app. Before we move to Engineer Joseph, if there's anyone who has a question, I want to take one question based on what Engineer Remy has presented. Any question, please? Yes, Sumunya.
All right, thank you very much for that presentation, Mr. Remy. Just wanted to also just get some clarity. The sterilization hold, how long does it take?
The sterilization hold, it will depend. In many cases, as we have seen, that this dry heat sterilizer, some people do change the element without considering the chamber volume. So the sterilization hold may vary, but it is required to be around 70% of the time for the whole cycle. If the cycle time was 120 minutes, it means 70% of that 120 minutes is the time needed for the sterilization hold.
Thank you. So now we'll move to the next presenter. Over to you, Engineer Joseph, and then we'll take other questions at the very end of his presentation. Over to you, Engineer Joseph.
Thanks. Hi, everyone. My name is Joseph Ngimbo from Tanzania. I'm a biomedical engineer from Mtwara Regional Hospital. I will take the second part of this presentation, we'll go through the maintenance and troubleshooting of dry heat sterilizers. Let's start with the maintenance. We used to do maintenance so that to make sure the machine is maintained on its normal operations, and it gives us the required results. So what is being done in maintenance? In maintenance, we do check some parameters. The first thing to be checked is to check the door. We check the condition of the door gasket. The issue with the gasket is to make sure that the intactness of the door and the gasket is to reduce the heat loss. So it is important to check on the gasket. If there is any damage, you have to replace it. So how can you remove and replace the gasket? The gasket is subjected to the door groove. So you need to carefully remove it and check it if you can see any corrosion or damage. And if there is a damage or any corrosion, you'll have to replace it with the same procedures. You fix it to the door grooves slowly and by using the special lubricants that have been used. For example, silicone gel, you can spray with the door groove where the gasket lie between it. You can conduct chamber inspection. If there is the need to clean the chamber, you clean it. This kind of maintenance is being done monthly basis, and it is well described here with the help of a picture that you can see the gasket and you can see the door. So when you close the door, they will come upon together to make a good seal. Another thing that we do during maintenance, we also check the insulation. This is the most important part that we have to check it, because when the insulation is poor, then will cause the burn to the user or anybody else that passing and touches the machine. So you need to check the intactness of these insulators. They are this kind of material over here, if you can see on the picture, the kind of like a sponge material wrapped around the chamber outward, so that they can prevent conduction of heat from the chamber to the surface of the machine. So you check the insulation. If there is an insulated part, you insulate it so that there is no any case of burn to the users. And this kind of maintenance, you check it in 6 months basis. Another thing we do in maintenance is to check the fan and the fan motor. In checking the fan and the motor, we want to check if the fan rotates since it's abnormal. If there is any abnormal sound, it means the fan is in different angle, which may also cause, we will see in the part of troubleshooting, will cause the variation of temperature. So the fan must stick on its position and rotate as it is required. Also, we check the fan motor so that we can lubricate the bearings of the motor to reduce the abnormal sounds that you can hear during the working of the machine. And this kind of maintenance, we do it in 3 months basis, or we can say quarter basis. So here in the picture, we can see the fan very clearly. It's where it is located. Its function is to circulate the hot air within the chamber. If I'm too fast, you can tell me. The other thing we check during maintenance is to check the heat coil. The heater is the core of the machine to produce heat, to produce temperature. So we check the heater if there is any damage, if there is any loose connection between the power cable and the heater. To check, we do maintenance to check if there is any ash and any dust on the surface of the heater. So we all check this, and if there is any ash or dust, you will have to clean it by using a blower or by using any piece of soft tissue to clean it and to remove the ashes and the dust. And if there is any loose connection between the heater terminals and the power cable, you'll have to to make sure it is connected tightly. Because if there is any loose connection between the terminal of the heater and the power cable, they might make a spark and cause the damage of the heater, even short circuiting. This kind of maintenance, it is also 3 months basis or quarter basis. And we can see very clearly from the picture the position of the heating element. Let's check another thing that we do on maintenance. The other thing we check is for earth integrity. It's the importance of checking the earth integrity is that to make sure the machine, if you touch the machine surface, there will be any feeling of shock that comes from the machine. And if there is a poor earth integrity, then you feel some shocks that comes from the surface of the material of the machine once you touch it. So we check if there is any loose connection. We check earthing wire and the thumb if they have a good connection and there is no any damage. And if you observe that there's something that is not good or damaged, you will have to replace it. If there is the earth wire is damaged or the thumb, you will have to replace it. Another thing is we check the tighten connection is appropriate, and we use appropriate tool to tighten it. And this kind of maintenance is done in 6 months basis. Yes, let's check another thing that we do in maintenance. We do check the temperature controller. We check the display. If it display correctly, means there's no any blinking of the display. There is no, maybe the display is not displaying at all. And if we realize that the display maybe is not displaying well, or it's not display at all, we will have to replace it. We check the connection between wire that comes to the display or the controller, because we have different kind of this temperature controller. We have this digital one and the manual. So we check the connection between the wires and the temperature controller. If there is any loose, we'll have to make sure that they connect in tight way. And this kind of maintenance we check in 6 months basis. As we can see from the picture, we have kind of different of temperature controllers. We have a digital one and the analog one. And this digital one, they come in different forms and shapes, like we can see here from the picture. Okay, let's move to another thing that we do in maintenance. We check for switches. In this kind of maintenance, we check the functionality of the switch. If it turns well, once you say I'm turning the machine on or off, that the switch gives you the results that you need. There is no any stuckness of the switch, or the switch, you switch it off, but there's still power flowing through the machine. So it's important to check all these switches. We check switch for a good wiring connection. If there is any loose connection, you tighten it. And this kind of maintenance it is been done in 3 months basis total. If there is any question up to there, someone can raise their hand and I will share the answers.
All right.
If otherwise there's no question, let me move to the other part of troubleshooting.
So I'd suggest you continue. We'll take the questions at the very end. Naomi, I've seen your question. We'll answer it once he's done. Thank you.
Okay.
Continue.
Okay. Okay. Those things that I was discussing with you that we do in maintenance, I have categorized them in 3 categories. Though those who maintenance we do monthly basis, and those who we do in quarterly basis, and those we do in 6 months basis, semi-annual basis. So here I highlighted that in monthly basis on these dry heat sterilizers, we check the door integrity, the gasket, and cleaning the chamber. In quarter basis, you can check heater coil and checking the lubrication and checking to if the necessary to lubricate the bearing of the fan. So we check the fan and the fan motor. If needed, you have to lubricate. In semi-annual basis, you check for terminal and wiring. Those connections between the connection of wires between the terminal for heating element, the connection of wire with switches and controllers, we do it in annual basis, semi-annual basis. Checking of earth connection and checking of temperature controller. Also checking the insulation material, if it is still in intact, we do it in semi-annual basis. Let's move to another part of troubleshooting of these dry heat sterilizers. As we know that as long as we use this machine, they encounter some errors and problems because of different factors. For example, the fact of users, maybe they have misuse of the machine, or the system, maybe electrical faults, or the machine itself. So they generate some errors and problems that we need to solve them. Let's check on this kind of problem that may be able to rise on these machines. The first thing to discuss is the temperature inconsistency. The uneven air circulation within the chamber can be due to heating element fault or improper loading of the item. This improper loading of the item is the most common problem associated with the users. They pack tightly so that they can maybe finish the work earlier. So it is wrong to pack tightly. There will be no air circulation within the items. The solution on this is to arrange the item with the space between them. Check for any obstruction in the airflow. If the sterilizer element is damaged, you will have to replace it. And you will have to ensure that the temperature controller is working properly, because it also can be a problem that causes temperature inconsistency. Another problem can be encountered with this machine is the door seal issues. A worn or damaged door seal can lead to heat loss. So if there is a heat loss, you'll find that you run your machine trying to raise up the temperature, but you will not reach the required temperature because there's in some point the heat is losing because maybe there's damage of gasket, so there is a loss of temperature. Solution is to inspect carefully and replace the worn seal. There is another problem of overheating. It can be due to faulty temperature sensor or malfunctioning thermostat. The solution is to have a sterilizer serviced and you check and replace the faulty component. Another problem is that you encounter this machine is incomplete sterilization. You load the material to the chamber. After sterilization, the material are not sterile. This can be due to the incorrect cycle selection, that the cycle does not allow enough temperature, does not allow enough time for sterilization at required, or there is overloading of the chamber. The solution on this is to choose the correct cycle based on an item that to be sterilized and to ensure the proper and the appropriate loading of the material that we have discussed, that the loading of the material should be in space to allow the hot air to move through the items. Okay, the another thing is no heat at all. You turn on the machine, the power supply is, you connected the power cable, but there is no heat at all. Cause of this can be power supply issues, but maybe there's no power flowing to the machine. Maybe there's a blown fuse, or there is any fault in connection. Maybe the connection between the machine switch that it receives the switch that it receive and distribute the power to the machine. So you have to check what is wrong with the specific point that caused no heat. The solution is to check power source from the socket. That this is important, that you may find, for us that we work in hospitals, they call you and say that the machine does not light on. But if you check on the socket, the socket is off. So it is important to check it from the socket that the power is flowing. If the socket is off, you'll have to turn it on. You'll have to ensure proper connection. And if you inspect and realize that there's a blowing switch, blowing fuse, you'll have to replace it. Okay, now let's check on important thing to be considered so that we can reduce a lot of errors and problem associated with these dry heat sterilizers. Let's check on validation of biological indicators. With the use of these biological indicators, it will help us to know if the material is being sterile or not sterile. It helps us to confirm proper sterilization. The use of these biological indicators, which have been designed to They have been designed to be killed during sterilization process. Also, if we do regular maintenance, it will help us to reduce this kind of errors and this kind of errors and problem of this machine. Cleaning of the machine, checking the connection with timely. If it is monthly basis, we will have to do it monthly basis. If the part of maintenance is to be done in quarterly basis, we'll have to adhere with the time of maintenance. So by doing maintenance, it will help our machine to work properly. Also, proper loading of the item, it will help us to reduce problem arising with improper loading. For example, a temperature inconsistency due to blockage of circulation. Maybe we found the user loaded the item up to the fan, so the fan won't be able to circulate the temperature. So it is important to check the proper loading. And for us that we work in the hospital, we'll have to remind the users this part of proper loading. Also, another thing is manufacturer instructions. We do not use our machine as usual. Every machine have instructions on how to use it, on how to pack, on how to make to conduct maintenance. So it is important for us engineers to adhere with manufacturer instructions. We don't do maintenance or any troubleshooting as usual, because during troubleshooting you may damage other parts. So it is important to adhere with manufacturer instructions, so that we make sure we do a corrective and the proper maintenance of the machine. Up to there, I can say thank you for listening, and let me pass to the hosts.
Thank you so much, Joseph, for the presentation. This is wonderful. We have learned a lot. So right now, I invite questions.
Naomi has asked the question that deal with steam sterilizer, but it's okay. We'll answer that. With this steam sterilizer, this machine that uses steam sterilizer, they have indicators that the machine is working or the machine is heating, because it has phases. It has the heating phase on the spot when you turn it on. So it starts with the heating phase. While heating phase, the machine has indicator that shows that the machine now is heating. Also, apart from the indicator that indicators that are used are these LED. Maybe there are different indicators, but there's this green LED. Once you turn on the machine, and they have been labeled that heating phase, the indicator will turn on. So will turn on with a green light. Also, to know that the machine is heating, you will check on the gauge. But because these steam sterilizer machines, they are in different builds. There are those with 2 chamber and there are those with single chamber. For those with double chamber, there are 2 gauges for pressure, because once the steam rises, it rises with the pressure. So the first thing to check if it is heating is by checking on the indicator. Another thing is to check for the gauge, the pressure gauge that reads the pressure on the steam generator or from the steam generator. So once the gauge is rising, so you know that the pressure is rising from the steam generator. Then the pressure won't rise if the machine is not heating?
Speaking of the steam sterilizer, there are several gauges in the unit, but if we look on the gauge that is usually a chamber pressure, you have to be keen with it so that if you see it holds for a specific time that the sterilization hold was supposed to stay, if it was, let's presume it was 5 minutes for sterilization hold, the chamber pressure, it has to hold that specific pressure for those 5 minutes. Because even though there will be a temperature loss inside, because we cannot completely isolate the temperature from the surrounding. There will be spatial temperature loss, but the boiler will have to, the heating element inside the boiler will have to encounter that amount of steam that is being lost inside. So by encountering it, it will ensure that the sterilization hold is successful. Otherwise, if the pressure inside the chamber drops even for 1 bar or 0.5 bar, it means the heating element inside the boiler cannot perform at a maximum load, or the material being used of that element is not the one that was supposed to be used inside, because you can have the element of the same wattage, meaning of the voltage, and you can know if the resistance is there. The resistance and the current is the same, the wattage, but you may find out that the resistivity is different because of the material that it makes it. So if you use a light duty heating element of the same wattage, it will not be able to heat the water inside the boiler to produce the steam at a required time.